In this video, in the Universe Sandbox simulator, I'll merge all the rocky objects in the solar system. That's all the planets, dwarf planets, moons, rings, and asteroids into one big planet. The gas giants and the sun won't be involved. There will be two different simulations. The first will be a realistic merger, and the second without fragment formation or heating. On my channel, we've already separately merged the main asteroid belt, the Kuiper belt, moons, and even rocky planets into one object. And now it's time to do the final part and merge absolutely all of it into one whole. Let's start the first simulation. This, I repeat, will be a realistic merger of all the rocky objects. And I'll start by adding all the moons to each planet. I've added them to Earth, adding to Mars, also the moons of Jupiter, Saturn, Uranus, Neptune, and also the dwarf planet moons for Pluto, Haumea, and Eris. There are also moons for Orcus, Makemake, and Quawar, but I'll add those a bit later. And since we're doing a merger of purely rocky objects, I'll have to remove the sun and the four gas giants from the solar system, deleting them. And that's it. Now the solar system has exclusively rocky objects. Now, next, I'll select all these rocky objects, go into their settings, into the motion tab, and I'll do this. I'll set them all to a distance of 20,000 kilometers. And I'll also completely zero out the velocity for all objects. As we can see, not all the objects moved where I wanted them to. Well, then I'll have to do it again. Selecting here, and Eris's moon Dysnomia somehow stayed behind. And I'm also setting it to 20,000 kilometers and zeroing the velocity. Now, as you can see, all these objects have gathered, roughly speaking, together. But that's not all. Now I'll set up a better location for them. And so, basically, everything's ready. Look at how it turned out. Earth ended up in the center, with Venus, Mars, and the large moons right nearby, as you can see. And also, besides all that, you see that I've added Saturn's rings. There are also rings for Jupiter and Uranus, also Haumea's rings, Quawar's rings, and even the rings of the asteroid Chiriclon. I also added Orcus's moon Vanth, Quawar's moon Waywat, and Makemake's moon S 2015. So, guys, everything is ready to start the simulation. Watch right here how Earth's characteristics will change during this whole merger, and I am, in fact, starting the simulation. Well then, the main part of the collisions is over. I'll hide the gases so we can actually see something. And we see that Earth really ate everyone here, roughly speaking. The mass has grown quite a bit, and now the rings are also colliding with Earth here. Let everything collide already. So, as we see, practically everything has collided with Earth, and here are some fragments returning back. Overall, we can see that Earth's mass has increased by 86%, and its radius by 23%. But if we turn the gases back on, we see Earth actively losing its matter. The temperature on it is very high, reaching as much as 5,800 degrees Celsius. Incredible. I'll fast forward time to let Earth cool down a bit. Well, Earth has cooled to 500 degrees Celsius and continues to cool. I'll stop time for now and save this planet. Let's call it New Earth, and place it in the solar system right in Earth's orbit, simply replacing Earth with this new planet. And so, now this new planet is located in the solar system. You can see its mass and radius right here. Let's hide the atmosphere and clouds for now. Let's just see what's here on the surface. And there's something unclear going on here. Now let's let time pass, let the climate stabilize, and I'll show you the final result. Time has passed, and as we see, Earth hasn't changed much in appearance. But what about the characteristics? In the end, the average temperature on this Earth is 604 degrees Celsius. That's a lot. It's even hotter than on Venus. It's all because the surface pressure is 513 atmospheres and the greenhouse effect is 625 degrees. And the number of atmospheric layers is as high as 143. If you hide the atmosphere and clouds, Earth's surface looks like this, as if there's ice here. Though it's strange. What ice could be here with these temperatures? But maybe it's all due to the extreme pressure. And in the end, we see there's a lot of water vapor in the atmosphere, 566 Earth atmospheres. This water in the atmosphere results in such high pressure. Carbon dioxide is 67 Earth atmospheres, plus there's sulfur dioxide at over 3 Earth atmospheres. Besides water, it shows there's also liquid carbon dioxide, but very little of it. And now about this ice at the equator, right at the equator, guys, which is totally surprising. It says here it's ice made of water. Actual water, guys, frozen at this temperature. And there's also a lot of water in this planet's mantle. I have only one explanation for why there's ice here. Because the massive surface pressure just froze it. I don't know. Write about it in the comments. And if we look look at the liquid on the surface, we see molten rock at the bottom of this liquid. That's how hot it is here. I even did it like this. And we can see on the dark side how red hot this planet is. It's literally glowing. Its axial tilt ended up being just over 5 degrees, and a day lasts just over 4 hours. The planet rotates very quickly around its axis, and naturally, the probability of life on such a planet would be very low or non-existent. In this case, there's only a 1,000% probability. Let's compare the new planet with the Earth we know, and we see the new planet isn't much larger than the regular Earth. That's because during the merger of all the objects, many fragments simply flew off into space. Plus, the extreme heating of the new planet's surface caused even more matter to evaporate, and in the end, the radius of the new planet is 7,816 kilometers, and its diameter is 15,632 kilometers. So, the final difference in diameter is only 2,890 kilometers. Now for the second simulation. I'll turn off fragment formation and heating to see what kind of planet forms if absolutely all objects collide and merge into one whole without any loss of mass. So, anyway, starting the simulation. So, Earth has swallowed everything up again, and Earth looks pretty interesting, right? There was no overheating this time. The temperature is great, but look at the mass. It has more than doubled, and the radius has increased by 27%. Just like in the previous experiment, I'll save this planet, call it New Earth 2, and place it in the habitable zone again, replacing the familiar Earth with this new planet. There, the planet has appeared. As we can see, gases are already starting to completely envelop the Earth. Most likely, those are gases from Venus again. Let the climate stabilize, then I'll show you the final planet. A lot of time has passed. I had to fast forward for a while. I didn't risk going faster than 1 month per second, but the climate has stabilized. Let's take a look at this planet. In the end, the mass of this planet is 2.1 times the mass of Earth. We'll get back to the size later. The average temperature is 158 degrees Celsius. Oh, well, this time it's much more reasonable, right guys, than in the first experiment. I think both you and I are curious to see what's on the planet's surface. And here we see this kind of ice along the equator again, and closer to the polar regions and the pole. Here we see some kind of dark-colored liquid, and this is likely not the water-based liquid we're used to. It appears to be some other chemical element. I'm looking at the composition of the oceans. It's still mostly water, over 7 Earth oceans worth, but there's a lot of liquid carbon dioxide, 0.33 of Earth's oceans, and most likely, this liquid carbon dioxide has tinted all this liquid in dark colors here on this planet. And also, besides that, there's a bit of liquid nitrogen and liquid sulfur dioxide. I wonder how liquid nitrogen could form here when the temperatures are so high. Well, the atmospheric composition here is interesting. As we can see, there are many different chemical elements, but it's mostly water vapor in the atmosphere. Then comes carbon dioxide, 2.5 Earth atmospheres, and other elements. In terms of percentages in the atmosphere, water vapor is 75%, followed by carbon dioxide at 10%, then ammonia at 8%, and methane at almost 2%. And there's also almost 3% nitrogen, and less than 1% oxygen, and also less than 1% of sulfur dioxide and argon here. And then there's this strange ice. Yeah, the composition here shows there's water ice, and there's a lot of it here. That's 1.5 Earth oceans. And there's also a lot of ice in the mantle, 140 Earth oceans. It's strange. How can there be ice here at these temperatures? Seriously, write in the comments what you think about this, because the pressure here is now only 20 atmospheres, not quite as hellish as it was in the previous part of the experiment. And this time the greenhouse effect is 177 degrees, with only 8% carbon dioxide. And the simulator shows the probability of life here is 0.624%. Well, a bit more than in the previous experiment. Let's also compare this planet to the regular Earth. As you can see, the new planet has become much larger than the Earth we know. The radius of the new planet is 8,083 kilometers. The diameter is 16,166 kilometers, making the difference 3,424 kilometers. So those are the results of the experiments. I think if it weren't for Venus's thick atmosphere, the resulting planet might have been more hospitable. If you liked the video, please give it a like and write a detailed comment about what you think of the experiment results. Thank you very much.